ask a question that it's very important that we ask when we're solving system of equations. Is there always a unique solution? In other words, am I ever going to have problems trying to find the solution? Or am I always going to be able to find an x and a y, one pair, an ordered pair, that works as a solution for both equations? The answer here is no, there's not always a unique solution. Yes, I might sometimes have problems if I'm trying to find an ordered pair that is a solution to both lines. Here's why. If I have two lines, anytime I have two lines, there are basically three different situations that could occur. One is they're intersecting. Those are the ones we've worked with most because those are the ones that will have one single unique solution. And that single unique solution is where the two lines cross. Okay? Now, here's another possibility if I have two lines. They could not cross at all. We call those parallel lines. If my lines are parallel and they don't cross at all, then there's no solution. Finally, and I'm going to erase my big no here so I have some space, it could be that I have what we call coinciding lines. That happens when I have two equations, but they really describe the same line. Maybe they're written in different forms, so it's kind of hard to tell that. Maybe they look like they're exactly the same. If you put both equations into slope-intercept form, then they would be exactly the same, so I'd be able to tell. But basically, if I have two equations and they both describe the same line, then I have coinciding lines. And what that means is every single point that is on one line is also on the other line. And remember, a point that's on one line and the other line is a solution. But here, that's every point. Every single point is a solution. So that's what we call infinitely many solutions. Every solution to one equation is also a solution to the other. So those are the three possibilities when I'm graphing two lines. Let's look at it on the calculator. Here's an example of two equations that both describe the same line. Usually, they're not this transparent, like 6 over 2 equals 3, and 5 divided by 2.5 equals 2. And the reason for that is on a calculator, I have to have my lines in slope-intercept form. That's the only way to graph them. So usually it's a little harder to tell because they're not both in slope-intercept form. So this would be an example of coinciding lines. If I change this a little bit, maybe change the second equation so that I now have y equals 3x minus 2 for the first equation and y equals 3x plus 7 for the second equation, well, now I have parallel lines. There's no solution. In fact, if I went and tried to find the intersection, which on a graphing calculator I do by doing second, trace, and then looking at option 5, which is intersect, I get an error because there is no solution. Those two lines don't have an intersection. There is no solution. And finally, if I have, say, negative 2x plus 7, these two lines are intersecting lines. So they will have one solution, and I should be able to find that one solution. And that solution is when x is 1.8 and y is 3.4.